Hello guys, hope you all are doing well. Welcome back to the channel Understanding Concepts of Physics. So today we are just continuing with our same topic, kinetic theory of gases, and today we are supposed to do only a single article, and that is Ferry's Blackbody. A scientist named Ferry devised a blackbody which absorbs almost 100% of radiations. Yes, we can say 99.99% can be absorbed from this Ferry's blackbody. So if you remember in the last video we had discussed about perfect black bodies. A body which absorbs 100% of its radiations incident on it is what is called as a perfect black body, and the coefficient of absorption is 1, reflection is 0, transmission is 0 for a perfectly black body. So in order to make a perfectly black body, Ferry made this kind of a body which is called as Ferry's black body, and which you can see on the screen. Ferry's black body, this is Ferry's black body. And before we read all concepts and all the terms and terminologies relating to this, I would just like to highlight on certain aspects. You can just see on the laser. You can see this double walled hollow sphere. So this is entirely a double walled hollow sphere, double walled. So it's a double walled hollow sphere. So there is a vacancy here, there is a space empty, and the outer surface is basically silver polished, in order that if suppose some radiation is striking this from outer side, then it can get reflected. Okay, so the heat radiation coming from the rest of the part of the body will be getting reflected because of the silver polished outer surface. Then if you just check this inner surface, it is lamp black coated inner surface. So this inner surface is basically lamp black coated. Now lamp black, basically it absorbs 98% of heat radiations. So let's say suppose this is my heat radiation which is incident. So this is getting reflected multiple times inside the body, and because this is lamp black coated, at each reflection 98% of heat radiation is getting absorbed. So like let's say suppose if there are 10,000 joules of energy which I am incidenting, let's say I am incidenting 10,000 joules of energy, this is just for sake of example, then at the first reflection 98% of that value would get absorbed. So 9,800 joules will be absorbed. So this is absorption, now. So reflection would be around 2%, reflection and transmission would be of 2%, and this would be 200 joules. Now of this 200 joules, so this 200 joules, 98% of this 200 will be absorbed, so that would be 196 joules will be absorbed, and only 4 joules will be reflected. So if you can see this, at this point 9,800 joules of energy would be absorbed and 200 joules would be reflected. Now at this point 200's ka 98% will be absorbed and 4 joules, that is only 2%, will get reflected. This is happening at the second reflection. So this is my second reflection, this was my first reflection. Now at the third reflection what will happen is, you have 4 joules which is incident on the third reflection, and out of that 4 joules 98%, that is somewhere around 3.92 joules will be getting absorbed at the third reflection, and 0.08 joules is getting reflected. So if you see, it's just a third reflection and the loss of energy is 0.08 joules out of 10,000. That's only happening for the third reflection. So if this ray is incident like 10-15 times in this, then definitely the amount of heat energy absorbed will be very near to 100%, and the loss would be very near to 0%. So that's why we say Ferry's blackbody absorbs almost 100% of the radiation. So you see, this is double walled hollow sphere, this is silver polished outer surface, this is lamp black coated inner surface. So inner surface is lamp black coated. Conical projection is because if you don't want to hit the radiation dead center and then it goes back, like you don't want the heat radiation to just come and go back. That's why we put a conical projection, and even lamp black is coated on the conical projection as well, so that heat radiation comes here and strikes multiple reflection at different angles so that it does not escape. Only the radiations which are going exactly dead center from after multiple reflection from this hole will get lost. I mean, we cannot record. But even if you see, you have seen that even if three reflection, after the third reflection only 0.08 joules of energy is going to get reflected for the fourth reflection, or it may go out. So 10,000 joules of energy is balanced with 0.08 joules. So this is the loss for third reflection. But if this goes for 10 reflections, then definitely the loss of energy would be very, very minimal. Okay, then this is the hole, that is the aperture. This is a small hole or aperture, and then comes evacuated space. So this space is basically evacuated space. There is nothing here, and the reason behind is, okay, if suppose, yes, definitely, even if it is the outer surface is silver polish, however polished this surface is, it will send some heat energy from the outer part of this region to the inner part of this region due to conduction. Now, what is conduction? We have discussed that in one of the previous videos. You can just go and have a look at it. Now, because the inner surface of the outer wall is getting heated up, the air molecules present here will get heated up, and that air molecule, that hot air, will in turn hit the inner side of the inner wall, and that will make the heat travel from the outer region to the inner region. So you see, if we keep this space evacuated, like we have nothing over here, then there is no molecules, and if there is no molecule, then that means convectional current, that is heat traveling from outside to the inside, would be minimal, or we can just avoid it by a fraction. So you see, silver polished is making the heat radiation get reflected from the outside. Second, even if the heat radiation is passing because of conduction, evacuated space is going to make the number of molecules pretty less, so that the heat transfer because of convectional currents would be less. So a heat radiation which comes into this Ferry's black body is going to get trapped, and you can absorb 100% of heat energy in a Ferry's black body. So whatever we have discussed, we have I've just written that in words. Let's see one by one. Yes, so we start here. Ferry's black body consists of a double-walled hollow sphere with a small hole, that is also called as an aperture. Okay, this will help you in order to write it theoretically, in case if you in case if your board demands writing work. Then the outer surface is silver polished to reflect the radiation incident from other parts of the body. Then evacuated space. What is the reason behind the evacuated space? Evacuated space between the walls is to reduce the convectional heat transfer from outside of the wall to the inside. So just a minor change. Convectional heat transfer from outside wall to the inside. So it's just a English. Okay, convectional heat transfer from outside wall to the inside. And second last, inner surface is coated lamp black. Why is it coated with lamp black? Because it absorbs 98% of heat at every reflection. So how this happens, I just showed you it over here. So how it happens, this is for the first reflection. This is for the first reflection, this is for the second reflection, and this is for the third reflection. Okay. And then we have this Ferry's black body absorbs almost all radiation incident on it, because like if the radiation is trapped at least for 10 or maybe some 5 or 6, even if you have seen that only 3 reflection makes the heat radiation go to almost 0. And the hole is the black body, and just remember that the black body is the area. When you are considering what is the area of a Ferry's black body, then you are supposed to study the this is the area of the black body and not the entire, because this is the thing which is going to absorb the heat radiation. We are actually reflecting the heat from this part, so we don't want heat radiation entering from the other parts of the region. So yes, this is all about Ferry's black body. In case you haven't taken a screenshot of this notes, you can just click it now. All set. Okay, and for the diagram, this is the diagram. You can just click on this as well, taking a screenshot. So winding up, in case you haven't subscribed, please do subscribe my channel and follow me. You can just keep a track of it. You can hit the bell icon so that you can get the notification. Thank you so much. Bye.